and welcome to the second part of lesson 9. We're going to have the derivatives of basic transcendental functions, namely trigonometric functions, exponential, logarithmic, and of course, the inverse trigonometric function. Let's start with trigonometric functions. Okay, so let us have this assumption first. Let u be a differentiable function. Okay, so we have now D9 and D10, which are the sine and cosine functions. So first, let's have the derivative of a sine function. So we have the derivative of sine u equals, it's just the derivative of cos u. Then we have here the derivative of u with respect to x. So the reason that we have u here is because take note that the angle, okay, for the trigonometric function, which is this here, u, okay, can be another function also. Hence, we're going to apply chain rule. Okay, so actually this is an application of chain rule here. We have du and dx. So let's have an example. So for example, we are asked to find the derivative of sine of 3x plus 1. So again, we just need to remember that the derivative of sine is cosine. So we'll have cosine of 3x plus 1, but take note there is here the derivative of u with respect to x. So do not forget du dx. That's why we have here derivative of 3x plus 1 with respect to x, because again, this is our u. Okay, 3x plus 1 is our u. So we need to get the derivative of 3x plus 1, which is simply 3. Okay, and of course, rearranging this one in such a manner that all the numerical coefficients is found at the left. We have 3 cos of 3x plus 1, and this is already the derivative of our given function. So again, the derivative of sine u is just cos u, and if there is an expression or function, okay, within the angle, we simply use chain rule, which is du dx. Next, let's have the derivative of cosine. Okay, so we have now d10. So if d9 is derivative of sine, d10 is the derivative of cosine. So what is the derivative of cosine? It is actually sine. So they are actually just the opposites. But however, there is a catch here. We have a minus sign. Okay, so the derivative of cosine is the negative sign of the angle or the given function here. So we have the derivative of cosine u equals the negative of sine u times the derivative of u with respect to x. So let's have some example. So let's try to use the same u here. So instead of sine, let's have cosine. So the derivative of cosine of 3x plus 1. So again, derivative of cosine is simply negative sine. So we will write negative sine. Then just copy whatever is the angle, and then get the derivative of whatever is inside the parentheses or whatever is your angle, which is 3x plus 1. So we have it here, and solving the derivative of 3x plus 1 is 3. Rearranging it, we have negative 3 sine of 3x plus 1. Okay, now we need to know where does this equations, or rather formulas, come from. So let's start with sine. So instead of sine u, I'll be using sine x. So let's try to use the limit definition to prove that sine x, the derivative of sine x rather, is equal to the cosine of x. So again, this is the limit definition. We have f of x plus h minus f of x all over h as h approaches 0. So take note that our function is sine x. So we simply substitute x plus h to our sine function here, and then f of x is simply sine x. Okay, now observe that this is sine of x plus h. Hence, we can apply the sum difference rule of trigonometric functions, specifically trigonometric identities. Okay, so we have the sine cos cosine. So if you can remember that, the sine. So we have the sine of, try to write it here, a plus b is simply sine of a cos of b plus cos of a and sine of b. So that's where this expression here, okay, came from. So we have the sine cos cosine. Okay, then we have now this. Then we try to rearrange in such a way that we can factor out. Okay, try to observe the numerator. We have a common factor here of sine x from the first and the last term. So we rearrange and then we factor out sine x. Okay, then we continue. So if we continue, we try to separate. Okay, we separate these two expressions here, or two terms. The reason that we separate this, it's because we need to cancel out. Okay, we need to cancel out cos h minus 1. But for us to cancel out cos h minus 1 and of course sine h also, we need to separate them so that we'll have this. Okay, so observe that instead of cos h minus 1, we have now 1 minus cos h because we have factored out the negative sign. So the reason why we have 1 minus cos h over h, it's because this part here is actually a theorem. It's a theorem, a limit theorem. And also we have sine h over h. So take note that h is approaching 0, so we can actually apply our previous theorem in trigonometric, limits of trigonometric functions. So we have the limit of 1 minus cos h over h as h approaches 0, which is 0. Take note, this is 0. And we have the limit of sine h over h as h approaches 0. This is 1. Okay, so we'll have this, so sine of x times 0 and the limit of cos x times 1. So of course, if it's 0, so it's already cancelled out or gone, it's 0. And then we have the limit of cos x as h approaches 0. So take note that we don't have any more the variable h. So we simply have cos x. Then if we generalize, instead of having x, okay, as our input value, what if it's a function, which is u? So we're going to apply the chain rule. So we'll have the derivative of sine u instead of sine x be equal to sine u, and then we have this part here du dx because of chain rule. Okay, so this is the proof for the derivative of sine u. Let's proceed to the derivative of cosine. So actually it's similar in process. So we'll use the limit definition again. Okay, so we know this part, but here we have now cosine. So take note that cosine of a plus b is cosine of a cosine of b minus minus sine of a sine of b, or we have the cos cosine sin pattern. So again, it's trigonometric identities. Okay, so that's why we have cos x cos h minus sine x sine h minus cos x. Then if you try to observe, we have a common factor of cos x, so we flip and and then factor out cos x. And in the same manner, just like in sine, so we factor out the negative here, so that's why we have 1 minus cos h. And then for this, since we have here a minus sign, so that's why we have a negative sign here. Okay, so of course, if we try to separate, we have now limit of 1 minus cos h over h, and here we have limit of sine h over h. And of course, we use the scalar property or the constant multiple property of limits. That's why we have minus limit of sine x here. And we know that 1 over cos h over h as h approaches 0 is 0, and sine h over h as h approaches 0 is 1. So in similar fashion, we'll get, okay, so here we have the limit of sine x, but take note there's a negative sign here. That's why we have now negative sine x. And if we generalize, okay, so we'll use u. Again, it's a function, so we apply chain rule. That's why we have now du dx here. Okay, so this is D10. So the derivative of cos u equals negative sine u du dx. And we have our proofs. Okay, so let's have the tangent and cotangent functions in the next video. See you later.